Hello aspirants, welcome to another video of mathematics series. In this video we will discuss about the complex number. So let's begin. So first of all, let us know about imaginary number. So a imaginary number is a quantity whose value is root under -1 and is denoted by I or iota. This imaginary number has some properties which are I square equal to -1, I cube equal to I to the power 4 equal to 1, and I to the power plus minus n equals to I to the power plus minus k, where n belongs to natural number and k is the remainder when n is denoted by 4. Now for any positive real number a, root under minus a is equals to I root a. For any two real numbers a and b, we have root a into root b equals to root under ab if at least one of a and b is positive. Root under a into root under b is equals to minus root ab if a is less than 0 and b is less than 0. If a and b are real numbers, then a number z equals to a plus ib is called a complex number. Real number a is known as the real part of z and b is known as the imaginary part of z. We write a equals to real z and b equals to imaginary z. A complex number z is purely real if imaginary z equals to 0 and z is purely imaginary if real z equals to 0. Now for any two complex numbers z1 equals to a1 plus b1 and z2 equals to a2 plus b2, we define addition of z1 plus z2 equals to a1 plus a2 plus I b1 plus b2. For subtraction, z1 minus z2 equals to a1 minus a2 plus I into b1 minus b2. For multiplication, z1 into z2 equals to a1 a2 minus b1 b2 plus I into a1 b2 plus b1 a2. For reciprocal of 1 by z1, the value will be a1 by a1 square plus b1 square minus I into b1 by a1 square plus b1 square. For division z1 by z2, the value will be z1 into 1 by z2, which is equals to a1 plus ib1 whole into a2 by a2 square plus b2 square minus I into b2 by a2 square plus b2 square, which is equals to a1 a2 plus b1 b2 whole divided by a2 square plus b2 square plus I into a2 b1 minus a1 b2 whole divided by a2 square plus b2 square. Addition is commutative and associative. Complex number 1 equals to 1 plus 0i is the identity element for multiplication. Every non-zero complex number z equals to a plus ib has its multiplicative inverse 1 by z, also known as the reciprocal of mod of z, such that 1 by z equals to a minus ib whole divided by a square plus b square equals to z bar by mod z square. The conjugate of the complex number z equals to a plus ib is denoted by z bar and is equals to a minus ib. For any three complex numbers, we have z bar equals to z and z plus z bar equals to 2 times real z, z minus z bar equals to 2 times imaginary z. If z is equals to z bar, then it will denote that z is purely real. Z plus z bar equals to 0 will denote that z is purely imaginary. Now z into z bar will denote real z square plus imaginary z square equals to modulus of z square. Now z1 z2 bar equals to z1 bar into z2 bar. The value of z1 by z2 bar will be z1 bar by z2 bar, where z2 not equals to 0. Now the modulus of complex number z equals to a plus ib is denoted by modulus of z and is defined as z equal to root under a square plus b square, which is equals to root under real z square plus imaginary z square. If z1, z2 and z are three complex numbers, then modulus of z equals to 0 will denote that z is equals to 0, that is real z equals to imaginary z equals to 0. Next, modulus of z equals to modulus of z bar equals to modulus of minus z. Minus modulus of z will be less than equals to real z, which will be less than equals to modulus of z. Now minus of modulus z will be less than equals to imaginary z, which will be less than equals to modulus of z. Now z into z bar is equals to modulus of z square. Now modulus of imaginary z to the power n will be less than equals to n times modulus of imaginary z into modulus of z to the power n minus 1, where n is a real number. Now modulus of real z plus modulus of imaginary z will be less than equals to root under 2 modulus of z. A complex number z equals to x plus iy can be represented by a point p of x comma y on the plane which is known as the Argand or Gaussian or complex plane. The length of the line segment OP is called the modulus of z and is denoted by modulus of z. From the figure, you can clearly denote that modulus of z equals to root under x square plus y square, which is equals to root under real z square plus imaginary z square. The angle theta which OP makes with the positive direction of x axis in anti-clockwise sense is called the argument or amplitude of z and is denoted by argument of z or amplitude of z. Clearly tan theta equals to imaginary part of z by real part of z. Let OP equals to r and angle XOP equals to theta. Then x will be equals to r cos theta and y will be equals to r sin theta. Therefore, z equals to x plus iy equals to r cos theta plus I sin theta. This is known as the polar form of the complex number z. The Euler's notation are e to the power plus minus I theta will be equals to cos theta plus minus sin theta. Therefore, z will be equals to r into cos theta plus sin theta, or z will be equals to r to the power plus minus I theta, which is known as the Eulerian of z. This was all about the complex numbers, and this was all for today. We'll meet in the next video. Till then, like the video, share the video, comment on the video and subscribe to our channel, and do check the link in the description for the PDF notes. Thank you, goodbye, take care, Jai Hind.